Welcome back to video number 2 in our series where we are talking about the Pythonnet library. So this is going to be the library that allows us from Python to plug into the CLR, which will then give us access to a lot of the different components and class libraries that we normally are only allowed to use in the .NET framework. So this is going to be kicking off more of the coding aspect. In our last video, I wanted to give you more of the context. I wanted you to understand what .NET was, what .NET framework was, what the CLI was, and all this different stuff. So now that we have that background, we can start moving into the, okay, this is all great and everything, but let's actually start coding. And so basically what I've done is I've created a Jupyter notebook. It has a lot of different content on here. Some of it is just reiterating what you saw in the previous video, but it's kind of giving me some time to, just write it all out. Along with providing this Jupyter notebook, I will also be providing a Word document that will basically summarize a lot of the key points that I made in that video, but also expanding on it a little bit. So trying to give you some more detail and some more context as to what a particular topic is and why is it important. But with that being said, you can see right now that for the most part, we have our introduction. So again, it's just talking more about what Pythonnet is, what was it designed for, and really at the core of it, if you really want to know, all of it is really doing is that it just allows us to access that CLR component from Python. If you don't remember, the CLR is short for the Common Language Runtime. And the Common Language Runtime is basically a runtime environment that is provided by the .NET framework, and it runs the code that we write and compile, and it provides services for us. So things like memory management, garbage collection, type safety, a lot of the complicated stuff behind the scenes that normally we would have to manage, the CLR will take care of that for us. So it's a really cool tool to have, and it makes the development process easier. And so the CLR as a tool lives in what is called the Common Language Infrastructure. The infrastructure is really the framework that defines the roles, so that way you can, in essence, leverage these benefits. In order to make this tool run the way it needs to, everything has to follow a certain group of rules. And if you don't follow those rules, it's really hard to provide the standardized services that the CLR does. And so the Common Language Infrastructure basically defines the key things that you need to do in order to be CLR compliant. And so again, that was covered in the last video. This is more just giving you basically a reiteration of what I've said in the previous video, but maybe just a little bit more detail. Now, naturally, some people might want to ask, well, what are the benefits of using the Common Language Runtime? Well, obviously, there's a performance improvement. There's the ability to easily use components developed in other languages, so things like F#, C#, VB.NET, I think C++ too, if you kind of wanted to technically, if you said it in essence, but it's for another day. But yeah, there's a lot of different components that might be written in other languages that we can now use because of the CLR. And things like inheritance, interfaces, overloading. So all these different types of ideas and frameworks can now be leveraged because of the CLR. There's other things too, like garbage collection, custom attributes, exception handling. More of the things that I would say are behind the scenes, and if you're really starting to get more in that complicated software development component, then these are definitely services that it's nice to have being offered for you, because it takes the whole process of developing your software a lot less time. Now, with all that being said, how do we plan to use this particular library in our tutorials? Well, one of the big things I know a lot of people like doing is forms, right? So everybody likes to be able to build user interfaces where the user can, click a button and then it, pops out a script or something like that. So there's definitely going to be a tutorial at some point where we'll walk through how to build a form using Pythonnet. And then additionally, we're going to also see how we can leverage different assemblies that were built in a different language and leverage them through Pythonnet. So things like the Excel interop library. There's other libraries that will allow us to connect to different databases from Pythonnet. Just really, I would say, as if you could imagine, they probably have it. I mean, they have, I would say, web scraping. There's components of it. There are, like request libraries. There's internet libraries as well, like to be able to like control like the internet connection to your system. What's some other ones? Yeah, I mean, there's like data type stuff. There's even like, I would even almost call like a pandas version of this, of a library in essence. I mean, I've only explored a little bit of it, so I'm not going to go out there and say, oh yeah, it's pandas. But I mean, it had a lot of features where I'm like, wow, this is reminding me a lot of pandas. And so we'll be able to leverage that library because of Pythonnet. So it's a really cool library. It just kind of takes a little bit to kind of, I would say, get up to speed with it. Okay, so with that being said though, the first thing you need to do is you need to install the library. And so this is a little bit deceiving because we're going to install it and then we're going to import something that sounds completely different than what we just actually installed. So that just makes things confusing, but regardless, it's not too bad. So to install Pythonnet, it's simply pip install Pythonnet. And so if I go up to my Anaconda, what is it? Pip install Pythonnet, right? Now I should already have it, so I shouldn't have to worry about it. Yeah, so it already tells me that I have the library, so I'm all fine. But normally it would install everything for you, and then after that, you can go ahead and use it. Now, for some of you, if you didn't know this, you can actually run Jupyter Notebooks from Visual Studio Code. I didn't know that. I learned this like a couple months ago, and I was like, whoa, like this is kind of cool. And so now I'm like able to run all my Jupyter Notebooks from Visual Studio Code. And I mean, it's a little bit different, but honestly, it's not too different. And I kind of like it for the most part because I kind of feel like I get more like control over like the themes and everything like that. But, so for the most part, you're going to see a lot of this stuff, the Jupyter Notebooks and Visual Studio. Okay, so once we've installed Pythonnet, we need to import the library. To import the library, it's really simple. It's import CLR. Now, again, you would think import Pythonnet. Nope, it's import CLR. And then to run your cell, it's simply Shift Enter. Oh. No. Perfect. I think it might have already run that one, so that's probably why it's doing it. Okay. And so once you've done that, you're good to go. And then from here, you can now start accessing the different components of the CLR library. Now, before we get started, we need to understand how to import modules and load assemblies. So if you don't remember, the CLR gives us access to different things, different templates, different class libraries. From this point forward, we'll call these kind of class libraries namespaces. So these are basically collections of things called types. These types can represent different things like objects and all sorts of wonderful things. The CLR allows us to import these namespaces. And so when we import these namespaces, we're basically importing all the types that exist in that particular namespace. To give you an example of what this would sound like, imagine I was to import the Excel namespace, right? Or the Excel interop namespace. That would give me access to the application object type. It would give me access to the range object type. So there is an inherent hierarchy behind it, and it's in essence something similar to VBA, but you just want to understand the naming convention is a little bit different. So a namespace is basically like a collection of similar, I want to say similar, but they're in common in some fashion. So these are a collection of types that kind of fall under the same category. So it's like, I have a range type. I have a workbook type. Well, these all kind of have the similarity in the sense of like, they all come from Excel. So it's part of the Excel namespace. So to import a namespace, it's pretty straightforward. If you want to import the entire namespace, it would just be something like import system, right? So it would just be import and then system. If you wanted to import a particular type from that namespace, it's just like you would normally do in Python. So it's from namespace name and then import the type that you want to import from that namespace. If I want to import all the types, it would be from System.Collections import everything. So again, different ways on how to do it, but it's very standard in the sense of if you've kind of seen it in Python, it's pretty much identical to what you would be doing with Pythonnet. Okay, but this is assuming that the particular namespace is loaded. If that namespace is not loaded, you can't import it yet. You have to add a reference. So to add a reference to a namespace, or assembly in this case, what you first have to do is do import CLR. You know what? I just realized that this is not what I wanted it to be. Where is it? There it is. I'm going to try that really quick. Perfect. Okay. Sorry, it was all in the same line. I was like, that's not right. So again, you would just import CLR like you normally do. And then you would call CLR the add reference method. And then you would specify the, well, in this case, the namespace that you want to add a reference to. So in this case, I'm saying, hey, add a reference to the system.windows.forms namespace. And once I've done that, I can start importing the types just like I was doing right up here. But it's very, very important you run this line first before you run this line. So this one, oh geez. Oh, God, I keep double clicking it. This one has to be executed first before you execute this one. Otherwise, you will get an error. On top of that, you have to be really careful about what you look for online. If you go online and say, for example, you say, hey, how do I import Excel, right? I just got to add a reference to the Excel interop namespace, right? Oh, baby. That's when things get all sorts of messy. A lot of the material online can be referencing IronPython. IronPython and Pythonnet operate very differently. Yeah, they're in essence the same thing, but Pythonnet is the more, I would say, up-to-date one. And so it's not to say you can't import the Excel interop namespace, but it's going to look very, very different than what you would be doing normally in IronPython. So you just have to keep that in mind. Sometimes when you go online, you might be seeing something, double check to make sure it's not for IronPython, and make sure that same, I guess, line could be effectively used in Pythonnet. So again, to load a reference means basically you're adding an assembly, which is a collection of namespaces, and those namespaces have types. So in assemblies, namespaces, types. I've now imported the forms type. And so once you've done that, you're good to go. Okay, so now that we understand how to import modules, load assemblies, and import those types, let's move on to the next topic, generics. Because we can now access this world of .NET, we get to access a new arsenal of tools, right? Yay. One of the tools we're going to be able to access is something called generics. A generic, in simple terms, allow for the idea of something called type parameters. A type parameter is just a way of building a class or defining a method in such a way it delays the specification of one's type until the class is instantiated or the method is called by the client code. Generic classes and methods combine reusability, type safety, and efficiency in a way that their non-generic counterparts cannot. Pythonnet supports generic types. A generic type must be bound to create a concrete type before it can be instantiated. Generic types also support the subscript syntax to create bound types. Let's walk through an example, right? It's all fun and games, but this is all just interesting stuff until we do it. I'm going to explain a little bit about what generics are, but I think it's easier to kind of understand what's going on when you see an example. And just as a reference, a lot of this stuff I'm getting here, it can actually be found on the Pythonnet website. So If this sounds really familiar, it's probably because I got it from here. A lot of what I usually do is I'll just kind of take what they do. If I need to expand on something, I'll expand on it. Or if I need to, change a little bit to kind of just, I think, re-emphasize something, that's usually what I do. All right, so the first thing that we need to do is we need to add a reference to the System.Collections assembly. So what we're going to do is, now that we have the CLR, we're going to do the add reference method, and then we're going to pass through a string. It's going to be, what is it? System.Collections. The collections assembly allows us to access things like dictionaries and just different things, like also like generics as well and things like that. I guess if I really wanted to be fancy, I could just go and show you online, right? So we will say System.Collections. Okay, and so this is the namespace. And so with the System.Collections namespace, you can see there's things like an array list, hash tables, queue, dictionaries, there's stacks. So I would kind of call it almost like the data structures in essence. That's really what you can kind of think about it as. But they give you access to these different types of types. And here we go again. I'm going to be saying type and type all at the same time. So now that we've created a reference to this assembly/namespace, we can start importing its types. So we'll do from System.Collections.generic import dictionary. We have now imported the dictionary type. Now, we can also import some different data types because we might be using them down the road. So for example, maybe I want to create a dictionary of strings, right? So what I'm going to do is I'm going to say, okay, from system, just import everything. Okay, so now that we've done that, let's start going through some examples. Example 1, we're going to create a dictionary generic. We can specify what type we want the key and the value to be. This helps maintain a little more control over the process. In the first example, I'm creating a dictionary generic that requires the key to be of type string and the value to be of type string. This is kind of the essence of a generic. What I'm doing is I am saying you need to create a dictionary, but this dictionary must conform to the types that I require it. So if you want to add stuff to this dictionary, whether it be a key or a value, they both must be a string. So what I'll do is I'll create a new variable. I'll call it generic dictionary1, and it will be a dictionary. And then we'll put our little square brackets. And so what we now do is we need to specify what we want the key, what we want the data type of the key to be, and what we want the data type of the value to be. And in this case, we specified string. Now, technically, it's like I wrote system.string, but because I imported everything from the system namespace, I just need to write string. If I didn't do this and I just imported system, again, it would just be system.string. And again, just to emphasize, here I'm going to create a dictionary. It's going to be a generic. That generic means you've got to follow my rules when you want to insert things into my dictionary. You want to insert a key? Go right ahead, but it has to be a string. You want to insert a value? Go right ahead. It just has to be a string. Okay, so that's one example. They don't always have to be the same data type. In fact, they can also be different ones. So we'll do a generic dictionary2. But you know what? I want this one to have a string as the key. And then I want the int32 to be my value data type. So this is going to be a dictionary where the key is a string and the value is int32. And again, int32 is just coming from my system namespace. No, system namespace. I always kind of get them mixed up. It's like namespace, assembly. I mean, to be honest, like I think it's kind of all, in essence, really kind of the same idea, but I'm sure there's probably a more formal, but when we get to that point, we'll get to that point. Okay, so that's one of a mixed type. And then in this final one, what we're going to do is we're going to do another generic dictionary. But with this one, I'm expecting my dictionary to have a string as a key, but I'm going to have the final one be something called type. A type in .NET, well, maybe not .NET to be extreme, but .NET and Pythonnet is just going to be meaning an object. So when I say type, I mean really an object. So if I wanted to store an entire object inside my dictionary, this is how I would do it. Okay, so now that we've done that, let's start adding some values to our dictionary generic. And technically it's not the 2-1, it's the 1. Okay, so we'll do generic dic1, and then there's going to be add. And then we'll add that key. It'll be my key 1. And then we'll put my value 1. Perfect. Generic dictionary 2. Oh. Let's jump ahead a little bit. And then this will be my key 2. And then it will be my value 2. Okay, and then once I've done that, let's grab a value from our dictionary. So we'll say for my key 1, the value is squarely brackets, and then it's going to be dot format. What is it? Generic dictionary 1. I'm going to access my particular key by simply using its name. So this is very familiar. We've done this in Python many times. That makes it really easy. Okay, so now that we've done that, let's see what happens. And then what we'll do is we'll do the same thing, but we'll do it for generic 2. Now, here's the kicker, right? Here's the kicker. For my generic 2, I can't have these be strings if we remember. They have to be integers. And we'll show what happens when you try to pass through, for example, like an integer, when you specified a string. Something really neat happens. At least I think it's neat. I'm sure some people don't think it's neat, but I think it's neat. All right, we'll do this one. And then, what is that? Okay, perfect. I thought I was missing something, but I guess I'm not. Okay, so now from here, we will call our generic dictionary 2. But here's the fun part. What I'm going to do is I'm going to call the add method again. This time I'm going to add my key 3. But this time I'm going to put in a string. And let's see what happens when we do that. And then we will call it and print everything out because it's fun when it prints out. And we'll call my 3. And then sorry, like I look at my notes and then I'm like looking back and I'm like, wait, what am I doing again? That's usually how it goes. Of the value is format, and then we'll do type. Perfect. So let's see what happens. Oh, well, this is also, I think, a good opportunity to show you what happens. So when you're doing this, unfortunately, this is one I would call like the drawbacks a little bit when it comes to Pythonnet, is sometimes the errors aren't really clear. And so you'll like, oh, no method given, really the issue is I had generic 2 up here, and generic 2, you can only pass through an integer, and here I was trying to pass through a string. That's no bueno. That's not going to work. So it did the right thing. It raised an error and it said like, hey, you're trying to pass something through. It's just that the error it gave me really gave me no indication as to why it was wrong. That's one of the drawbacks to this library, is sometimes it's not very clear where you went wrong, and it doesn't really give you a clear direction as to, well, how do I fix it? So I'll do my best to kind of like document this stuff, but part of it is like you kind of have to understand that the .NET component, and then also understand like the Python component. So you'll get in time. But it did do the right thing. It raised an error because I was trying to pass through something that wasn't correct. But here's the cool thing, right? So remember this one where it was trying to, we were trying to pass through that string. It did it, but this was the cool thing. In this case, it actually was able, because it basically was able to handle this. It knew how to handle it. So behind the scenes, it properly converted this to an integer. You can't always do that, because we just saw up here like, well, how do you convert my value 2 to an integer? Well, you can't. Well, I mean, I guess you can in a weird sense, but not in the sense that we're talking about. So it did the correct thing. It did convert it, and you can even see it because like now when you grab it, you're like, oh, wait a minute, like it is very much an int. So it did the right thing. It just did it behind the scenes, but you have to understand it doesn't always do that. It's not always able to do that. So that's one of the benefits of a generic, is it gives you more control over the process, because now you can say like, you know what? Hey, like you want to use this dictionary, you have to give me the types I'm expecting, because maybe I'm using this dictionary down the road and I'm going to be doing something like, I don't know, like adding all the numbers in it. You have to make sure they're numbers or I can't add them. So I think that's really a cool thing that we can now incorporate. And I think in future examples, I'll kind of show you how to expand on this topic and maybe use it with like other items from the collection namespace. Okay, so now that we've talked about that, we also want to start talking about fields and properties. And so definitions, right? Okay, so fields. A field is a variable of any type that is declared directly in a class or struct. Fields are members of their containing type. Generally, you should use fields only for variables that have private or protected accessibility. Data that your class exposes to client code should be provided through methods, properties, and indexers. Fields typically store the data that must be accessible to more than one class method and must be stored for the longer than the lifetime of any single method. At this point, we should know what a property is, so I won't go into kind of what that is. You can get and set fields and properties of CLR objects just as if they were regular attributes. Now, fields. It's kind of a confusing topic, but for me, when I heard like declared directly in a class or structure, I think that kind of gave me an idea, because it's something like, okay, this is something like I'm not going to be necessarily assigning at runtime. This is more something like, hey, this is going to be defined beforehand, and like I don't have any control as to changing it. It's more of like, hey, these are the fields that are just there and things like that. I don't really have that ability to necessarily change anything about it. And so I'll kind of show you what they look like a little bit, but I think that's just, it's going to have to be a topic where we kind of just wait a little bit, and we'll kind of see like how to leverage these things more down the road. But again, if it's a little bit confusing at this point, I get that, but we'll kind of explore it more as time goes on. Okay, so the first thing we're going to do is we're going to import a new namespace. So we're going to import the environment namespace. And so let's do some more research. Yay. Whew. There's a lot. So when I'm talking about a lot of namespaces and stuff like that. There are a ton here. I mean, this is just some of them. And if this doesn't scare you a little bit, you are a brave person, because it scared me to death. We need the system namespace. So the namespace, and then we have what we call the environment class. So the environment class, this is like also our type. And you can see all the properties that exist with this particular environment class type. So there's one called machine name. This will return the machine name. I can see my username. I can see my version, my operating system version. Let's start kind of seeing what we maybe can learn about our environment, because where's the fun if we don't know what our machine is, right? So we'll get something like my machine name, and we'll do something like environment machine name. Let's do what else? What else we got? OS version. There you go. My OS version. This will be our environment, and then OS version. I hope it's that one. Oh no, it's all cap. Okay, OS version. And then what we'll do is we'll print out all of this. So we'll do print. My machine is called dot format, and then we'll do my machine name. Print my operating system version is, and then we'll do sorry, I'm like being nitpicky now. I shouldn't be like that. Format, and then my OS version. So we'll run it right now just to kind of show everyone what's going on. Well, right now this is just doing something, but don't worry about that. Okay, so you can see here my machine called is desktop, this ugly mess. And then my operating system version is Microsoft Windows NT 10.0 and all that stuff. So I think this is kind of starting really getting into the cool stuff about this library. Like, so now if you think about it, like we've just got access to literally all this stuff, and we're not having to write any of this. So things like, oh, snap. Like we have things like, tuples. We've got time zone class objects. Like, what does that even mean? Right? I mean, this is just some interesting stuff. And that was just literally one class from one namespace. We have all of these namespaces we can potentially be using once it finishes loading. So there was one on here. Yeah, I'll let it finish running. I'm too lazy for it to wait. Okay, so there's some other things that we can do. So inside the environment class object, there is a type, or sorry, there is an attribute property called exit code, which is just the exit code of a process. And so if, for example, if a process has not completed successfully, the environment exit code would be 1. If it did, complete successfully, it would be 0. So what we're going to do is we're just going to show you, hey, if I wanted to ever change this property, it's very straightforward. I would just go like, okay, set it to 1, and means, oh, it never successfully, finished or whatever it was. And then maybe you want to say, actually, no, it did. So how you would use this, it really depends. I mean, it really just depends. But again, this is more just driving home the idea you can set and you can grab properties. So it's really important to understand that component. And so if I hopefully run this, nothing pops out because, again, it wasn't printing anything, but this did get changed. And if you wanted to, you could prove it to yourself by actually printing it. Okay, so I'm going to come back here really just quickly. But again, this is crazy. Like, you got Visual Basic, C#, JScript. There's just so much here. And I barely have gotten the chance to read all of it. But the data, this is like the crazy one. This is like the one I was thinking like, it was more like pandas. Like there's just all this stuff. There's data row, there's data table, there's data column. I mean, I've been wanting to look at this one so much because it just seems like there's so much there that can be used. So I think that's why this library is so cool, is you can just start importing all these different class objects that normally like you never had access to. Okay, so that's talking about fields and properties. We're going to move on to the next topic, which is arrays. So arrays, we've kind of used them a lot in, Python and stuff like that. We just use lists and everything like that. We use NumPy arrays and all sorts of stuff like that. Using arrays in Pythonnet is a little bit different, but once you kind of get the hang of it, it's not too bad. It is a little bit different than anything we've kind of done. So what we're going to first do is we're going to import the array type. The array type does exist in the system namespace. And so we want to make sure that we import the system namespace and then import array. And so array is the type that we want to bring in. Okay, so once we've done that, we need to create a new instance of an array. You can have single dimension arrays or you can have multi-dimension arrays. If you want to create a single dimension array, it's pretty straightforward. We'll just create a new variable. We'll call it 1. We'll call our array type, and then it will have a method that is called create instance. And so once you've done that, it's called int 10, and you're good to go. So what you're really saying here is that it's only going to contain numbers, and it's going to contain 10 elements that are all 0. This is very deceiving. You would think like, oh, it's just going to create a single array and it's just going to have, 1 number and 10. No, it's creating a 10 element array that are all set to 0. So they're all going to be set to 0 and they're all going to be numbers. To prove that to you, I'm going to print my array. So I'm going to say, here is my array. And so we'll just put a little colon. And then we'll do format. You can't print arrays directly. You have to first put them in a list. You're going to do array 1. And I think that's it. Is that it? Yeah, that's it. Okay. And this is a lot, so just bear with me. Did it not print? I don't think it prints. Let me do this. It could be that too. It printed up there, so I don't know why it didn't print there. Did I maybe array create instance? Oh, I know why. I didn't put my little dot. Would help if I put my dot. So here you can see, here is my array. So it's just, again, it's basically a list of just 10 zeros. So again, a little bit, I would call it misleading. You would think it's, you would think it was just like, oh, you just create an instance and you're good to go. Oh, but if only. But reassigning a value is actually pretty straightforward. You would just grab the array, you specify the index that you want to change the value, and then you specify the value that you want to pass through. But you also got to keep in mind, you specified int, so you can't start mixing data types. That's one of the drawbacks. You can't just start necessarily doing that. Now, there's ways that we can work around that, but again, we'll save that for later down the road. At this point, this is one of the, I would say, the challenges of, especially if you come from a Python background, you got to realize that other languages, they're not as flexible as Python. Like if you say it's going to be ints, it's going to be ints. It's not going to be strings and ints. It's going to be ints. So again, it takes a little bit, but hopefully it's not too bad. Okay, so what we'll do is here is the value of my first element. If and we'll put our little bracket, and then I'll do format, and then I should be able to do array 1, and then from here it should be 0, bracket, right? Okay, and shift enter. Perfect. So you can see that it did get changed, so that's awesome. It means that it was successfully inserted. You could also, Well, this is just more of like, hey, if you wanted to declare an array, but here's an alternative way of doing it. This is also a way of doing it. So maybe I want a list of numbers. In this case, it's a tiny bit different. I'm going to specify the data type of my array, so everything that's going to be inside of it, and it's going to be all numbers, and it's going to be array 2. I'm just going to warn you, this is deceiving a little bit. Online, there's some examples out there. I'll put it on here before I post it. You would think like, oh, I can just do this method with like all the other ones, right? Ooh, if only. I think it's with the multi-arrays, like this can actually get you in trouble. But I'll kind of explain like what the workaround is and how we handle that. So once I've done that, what I'll do is I'll just copy what's right up here and print it. I can print it because everything needs to be printed. Shift enter. So you can see with this one, it now goes from 0 to 9. So works perfectly. All right, so we talked about a single dimension array. You can also have a multi-dimensional array. And so naturally, it's a little bit more complicated, but nothing I would call it anything substantial. In this case, what we're going to be doing is we're going to be creating a multi-dimensional array. It will only contain numbers, and it will be 2 by 3. So we'll have 2 rows by 3 columns. All right. And so what we'll do from here is we're going to change some of those array values. And so we'll say, okay, because right now, technically too, it's like it's still all 0. I want to change the first row. So we start at 0 because we're still 0 based. I want the second column because again, we are 0 based. So 1 is 2. And we'll set that equal to 100. And then we'll do a multi-array 1. This one, we're going to say, okay, change row 1, column 1. And then, of course, this is misspelled. It's row 1. And then we'll set that equal to 100 as well. And then here we'll do multi-array 1. Oh. And then what we'll do here is we'll say 0, comma 2, and then this one will equal 100. And so I'm going to take this one, and again, just to give you an idea of what this would look like visually, we'll say multi-array 1. So nothing super fancy at this point. And you can see, again, I understand it's like kind of misleading a little bit, like, oh, it's just a list, Alex. No, it is truly a multi-dimensional array, but to visually show it to you, I have to convert it to a list first. And so you can think of this as being row 1, row 2, row 3. I'm sorry, row 1, row 2, column 1, column 2, column 3, column 1, column 2, column 3. So again, sorry if that's a little bit confusing, but it is truly a multi-array. All right, let's move on to the second one. So naturally, you can do this multiple ways. If I want, I can do it like this. What I'm really saying is, hey, there's going to be an array, and that array is going to be containing another array, and that array is just going to contain numbers. That's how you should read it. Now, just visually to kind of help drive home the point, I found this nice little example online. Yeah, it's a little bit spaced out, but I think it's a lot easier to read. And so we'll do that, that, and that. And then here, I will show you what this would look like. Now, to kind of, I guess, give you the natural way of how this should look, what I can do, we'll say for array. Oh, wait. No, that's right. Okay, yeah. Yeah. Sorry, I thought I printed it wrong or something. What I'm going to do is I'm going to say, okay, for array in list array, yeah. And then what we'll do is we'll say, okay, we'll make this a list array too, right? So ideally what this is supposed to do is it's supposed to make it where I would say it's more natural. So now you have that kind of like multi-dimensional component. And here again, what it's trying to emphasize is like, oh, okay, like that was a list. That array was truly a list of just values. It's not just a collection. It is truly a multi-dimensional array. All right, so that's arrays. Let's move on to collections. So if you come from the VBA world, you should be pretty comfortable about what collections are. They're just simply a group of similar objects. And the Pythonnet library allows us to basically, I would say, manipulate these collections where we can iterate through them. So certain, namespaces and things like that, they might, have collections that belong to them, and we might want to be able to iterate through some of those collections. So for example, like, hey, I want to iterate through all my workbooks. Workbooks collection is a perfect example. It's a group of similar objects, and we can iterate through each one of those objects and then grab certain properties. So we're going to use an example from the system namespace. There is something called the app domain that exists in the system namespace. And so what we'll do is we'll create a new variable. We'll call it domain. We will call our app domain type. And then that one does have a current domain property. I don't know really what that returns per se, but I guess I could just look it up. Where's my system one? There it is. And this is kind of neat because, oh, here it is, perfect. So the app domain represents an application domain, which is an isolated environment where applications execute. This class cannot be inherited. So the app domain class has a property called current domain. That current domain is basically the application domain for the current thread, so the current thread that we are running on. What I'm basically doing is I'm saying, hey, for Pythonnet, what's your current domain? And once I do that, I can now figure out what all of the assemblies that I have loaded. So I can say for assembly in domain get assemblies. Praying to God I spelled that right. And that is a method, FYI. And so get assemblies, if we look here, let's see what it says. Where is it? Property value returns. It's the current thread method. Get assemblies. Maybe, you know what it would probably be if I had to guess? It's probably right here. Yeah, there it is. So it's because it's that kind of makes sense too. It's probably returning an app domain class object. And so that object itself, it's going to return the assemblies. So when you call get assemblies, the method, it returns, you can kind of see right here, assembly, but it's an array of assemblies that are currently in the application domain. So if you click on this, this will tell you the type of object. And so technically, like, oh, Alex, now that we have an assembly, like, what can we do with it? There's a lot you can do with it. You can get the things like you can get the name, you can get the object there, you can get all the types that were in an assembly. You can load it, you can load the file. I mean, there's just a ton you can do with it. But you have to always ask, like, okay, is this returning another object, or is this like returning like just a very basic type? And so, for example, if I want to grab the assembly name, I would just call my assembly object, and it has a get name property. And then if I want, what I can do is I can say, okay, now that I have that, let's print that name. And so we'll say, okay, print, and then we'll do assembly name. Man, my battery just dies so quickly. It's really frustrating, to be honest. And you can see right here, these are currently all the assemblies that I have running in my Pythonnet environment. You can see the ones I've loaded. You can see the ones that were already just preloaded for you. So there's a system.xml, a system.configurations, a Python runtime, a system, code generator and some other stuff that we aren't really going to get into, but it's letting you know what's there. So super useful stuff. And we're going to see this heavily when we start getting into the Excel library component, that we're going to have to really understand what this is returning and how we can extract all the information we need to do what we need to do. Okay, final topic, indexers. So some of you might have even caught on to this. We've actually been using indexers multiple times throughout this tutorial. But, you know, I guess just to be consistent, we can dedicate a section to it. If a managed object implements one or more indexers, you can call the indexer using standard Python indexing syntax. So, for example, I'm just going to copy it. I'm lazy and I'm not going to type anymore. All right. Perfect. All right. So first one is the key method. Again, I don't know if this is like the official way of calling it, but this is how I use it. So if you ever watch like one of my VBA videos, like you always see like, oh, here's the key method. Here we're using like the unique key that allows us to access a different object in our collection. We also have the index method. And so the index method is using the index of the particular object based on its position in the collection. You have to be careful because index can change depending on what type of collection you're working with. So to give you an example from VBA, if I was working with the workbooks collection, the index is determined by the order in which the workbook is open. So if I open book 2 first, it has an index of 0. If I open book 1 second, it has an index of 1. What the important part to understand there is it's the order in which they were open. But to give you kind of an alternative, the worksheets collection, so the collection that contains all the individual worksheet objects, that's a little bit more different. The index is determined by the order in which the worksheet appears on the workbook. So if sheet 1 is first, it's got an index of 0. If sheet 2 appears second, it's got an index of 1. So you just have to understand index is fine. You just have to understand how is the index determined. Here, I'm just showing you the different ways. We've used key method, index method, and then obviously if we want to access a multi-dimensional object, it's very straightforward. Hey, I want from my multi-array, from the first row, I want the third column. Bam. And just like that, everything worked fine. So at this point, I am going to close off the video. I think I've taken enough of everyone's time. Hopefully you found this video informative, and I think I didn't scare anyone away, hopefully. I think Pythonnet, again, once you kind of just understand that it's not going to be identical to Python, I think that's kind of the first thing you just kind of have to accept. It's not going to be identical, but there's a reason for it. You want to start using other objects from different languages, that's all fine and dandy, but not every other language is built like Python. And so if you want to start using those other objects, you're going to have to start conforming to those languages' role. That's why you're going to start seeing things like generics. It's not a bad thing. It's just saying, hey, Python's very flexible. We're not as flexible, but we're giving you something extra by not being as flexible. So once you kind of accept that, things move fine. I think there's still a lot that this library can offer you in the sense of, for the love of God, you have literally all these different namespaces. I mean, this is insane. There's so much here that you don't have to build, and now you can start getting access to it. So I think this is really exciting, and we'll kind of start going through this as little by little and just kind of understanding what we can do. I mean, you can see right here, there's a whole section dedicated to web, like web and UI. This is crazy. We have documents, we have forms, we have markup, we have media, we have the shells, we have shapes, we have, what is it, XML. You know, there's just so much here. It's overwhelming a little bit, but I think it's awesome. So yeah, I think at this point, if you have any questions, feel free to put them down in the comments below. And then I think in the next video, what we'll start doing is I'll show you a working assembly. So I'll show you one that behaves properly and does exactly what you would expect it to do. And then after that, I'm going to show you the Excel interrupt assembly, and I'm going to show you why that assembly doesn't work and why that inspired me to build the Excel object library, because things don't work the way they should. All right. So thank you again for watching, everybody. We will see you in the next video.